Hello everyone. In this video, we continue our look at basics of computers. In the previous video, we did define computer systems. We talked about classification of computers, and we also talked about characteristics of key characteristics of computers. In this video, we'll look at how computers have evolved over time, and some basic concepts that we need to know about computers. So we'll start by looking at the generations of computers and then move on from there. Computers have evolved over time. Okay. When we talk about computer generations, we are talking about changes that have taken place in the in computer technology with time. Um, there's constant research on how to make computers better. There's constant research on how to make computers better, and this research, which has been going on over time, has made computers to change. The technologies that are being used in computers has been changing. Okay, now the change that is as the change is taking place with the change in the different technologies, what you're going to find is computers are becoming smaller and they are also becoming more powerful. They are becoming faster, they are becoming more reliable, etc. So that is the idea. Okay, that's the idea. Now, when we talk about generations of computers, we have about 5 generations of computers. Now, these 5 generations that we have, um, they are guided, or the way that we classify these generations, we classify them based on the key technology that is used. Each computer generation uses a specific technology, to develop the different components of the computer. So we'll quickly look at the 5 generations of computers that we have, and then move on. The first generation, now as I'll be talking about this, I will not be mentioning the years. You can see them. My focus will be on the technology. So the first generation of computers, they used vacuum tubes for electronic circuitry, and they also used magnetic drums for memory. Now, you recall from the definition of a computer, we said a computer is an electronic machine that accepts inputs, process the input to give the desired output. Now, electronic output, we said electronic means it's using electric energy. Now, for this electric energy to be used, there's supposed to be a way of carrying that. There's supposed to be a circuit that will carry the electric energy. In the first generation of computers, vacuum tubes were used to make this circuitry. Vacuum tubes were used to make this circuitry. The result of this technology, in this technology, what you find is that the computers, the first generation computers, were very large. Because of the technology that was used, the computers were very large, and in terms of the performance, the computers were very slow. If we compare the computers that were used then to computers that are being used now, the difference in terms of speed is very visible. The difference is very much visible. We can easily see it. So that's about the first generation of computers. They used vacuum tubes for the circuitry and magnetic drums for memory. In terms of their performance, they relied, other characteristics we can talk about was that these computers relied on machine language. Now, machine language, the instructions that were issued to the computer, they had to be written in the actual language that the computer understands. Now, we talked about digital computers, and when we talked about digital computers, we said the instructions are represented using binary values 0 and 1. So in the first generation of computers, the instructions had to be written in ones and zeros, the actual language that the computer would understand. And these computers were only able to perform one task at a time. They're only able to perform one task at a time. This is an example that I got from Google when I was looking at I was looking for an image of the first generation computer. So this entire machine you can see here is one computer with the input, which was entered somewhere here, and the output was issued somewhere. Where exactly? Maybe it could be here, but I'm not saying this was the output. I'm just saying the input was done somewhere here, and the output was done somewhere here. So this entire machine is one computer. And if you look at its performance, maybe the calculators that we use today were even faster than this machine. That's the first generation computers. Now, the first generation computers, later on, people started looking at what alternative technology can we use in place of vacuum tubes. So they, in the second generation of computers, they introduced transistors. Now, transistors were smaller than vacuum tubes. And this resulted in computers becoming smaller. As computers became smaller, even their performance improved. They also became faster. Um, uh, just to show you. So this is an example of the second generation computer that again I found from from Google. If you look at the size, at least you can see that there's tremendous improvement in terms of the size. The size has reduced considerably. That's the second generation of computers. In the third generation of computers, integrated circuit chips were introduced. Now, integrated circuit chips, in making these chips, what happened was they got a number of transistors and squeezed them and compressed them on smaller chips. So they made a lot of these transistors to fit on a small chip. This resulted in computers becoming even smaller. They became smaller and they became faster. Yeah, they became smaller. They became. They also became faster. Even so, let me just show you this. Then come back to explain the next point. All right. So with the this is an example of a third generation computer. So in the first generation computer, we saw that the computer required some large space. Maybe it could, in a single room, you can only have one computer. But with the third generation computers, what we had was computers now, which previously used to be very large, they can now fit on a very small space, such as a table. So this is the third generation of computers. Now, in the third generation of computers, keyboards and monitors or display units were also introduced. Keyboards and monitors were also introduced. And it was now possible for computers to handle more tasks, more than one task at the same time. So this is the third generation of computers. First generation, vacuum tubes were used for the circuitry. Second generation, transistors. Third generation, integrated circuits were introduced. Fourth generation computers. In the fourth generation computers, um, thousands of integrated circuits were built on a single silicon chip, okay, in what we can call large-scale integration and very large-scale integration technologies. Remember, when we talked about integrated circuit chips, we said getting a number of transistors, try to fit them on a small space, on a small chip. Now, what has happened was that what was fitting on a small chip, we try to integrate more chips, we try to integrate more of those, to put more of those integrated circuits on a single chip. And the result now is that computers continue to become even much more smaller. They became smaller, and these are examples of fourth generation computers that we have. Fourth generation computers are very fast. In terms of performance, they are very fast. They're able to handle millions of instructions per second. Okay. Now, the fifth generation of computers. Okay. Now, depending on the books that you read, you find that this generation of computers, the fifth generation, kind of overlaps with the fourth generation and the fifth generation computers kind of overlaps. Okay. Just to show it here, for example, here you can see we said fourth generation, they started from 1971 to present. And again, here now we're saying fifth generation computers, we're talking about present computers and computers of the future. Now, fifth generation computers, they are built on super large scale integration of chips. These integrated circuits, we now integrate more and more on a single chip. Now, with fifth generation computers, there is an additional component that has been introduced. The component is this component of artificial intelligence. Artificial intelligence, we're talking about the science or a branch of computer science that tries to make computers more intelligent. So we are trying to incorporate intelligence into computers. So that is the idea. All right, that's the idea. So here we want to make computers exhibit the same intelligence that humans have. And to a great extent, there's tremendous progress which has been made in this area. Today, you are able to communicate with your computer using, for example, voice recognition. For those who have iPhones, there's Siri, and you can talk to Siri on using your voice. You tell it to say, do this. Can you find this number? Can you find me a restaurant? And it will search for the nearest restaurant in your location. On most Android phones, there's the Google Assistant application, which also uses voice recognition. You can issue an instruction to say, call Peter, for example, and that call is going to be placed. Or you want to issue an instruction, you just say something, and then that instruction is carried out. The idea, we want computers to be intelligent so that they can do more things for us. So these are the 5 generations of computers that we have. Okay, now what makes up a computer system. When we talk about a computer system, or when we talk about a system in general, a system is a set of interrelated components that work together to accomplish a specific task. That is the definition of a system. A set of interrelated components that work together to perform a task. When it comes to computer systems, the components we have are one, hardware, software, data, and the users. So these four components, they work together to accomplish a task. Now, very quickly, what is hardware? Hardware, we are talking about the physical devices of a computer, the physical components of the computer. Now, these physical components of the computer, some of these components are used for input, inputting data into the computer. Some of these devices are used for outputting data from the computer. Some of these physical components, by physical components, I mean the actual parts, the parts of the computer that you can touch. If you look at your calculator, for example, there is that display unit, that screen, which you are able to touch, see and touch. That is hardware. The buttons that you have, that is hardware. The casing of the computer. So those are the physical parts of the computer that we are talking about. Okay, so that's the hardware components. Some components are used for inputting data. Some components are used for outputting data. Others for storing data. So for example, most of you on your phones, you have memory cards, you have flash drives. So those are hardware components that are used to store data on your computer. Then we have software. Now, software, we're talking about a set of instructions that tell a computer about the task to be performed, as well as how to perform that task, how tasks should be performed. Hardware, the keyboard, the mouse, the display unit, they can't work without instructions. They can't work without instructions. So the instructions, those instructions which the computer will follow to perform a task, are what we refer to as software. Okay. Now, software comprises of two parts. The two parts are, one, there's a program, and secondly, there is the documentation accompanying the software. A program, this is a set of instructions written in a language that a computer will understand. And these instructions, they outline how a task should be performed. For example, if you want to send a voice note on WhatsApp, instructions are written, for example, on how the voice note should be composed, on how the sender, how the details of the sender should be specified, how the details of the receiver should be specified, at what rate should the instruction be sent. So those instructions are what makes up a program. Now, each program will come with accompanying documents. Now, these documents will outline the instructions on how to use that program, where to use that program, etc. So a program plus the accompanying document makes up software. A program plus the accompanying document makes up software. Data. Data, we're talking about isolated values or raw facts, and these facts are what the computer will work on. Remember, from our definition of a computer, we said it's a device that accepts input, work on the input to give the desired result. So anything that the computer will do, it will need the input. Now, when the input is entered on its own, it doesn't make sense. We need it needs to be worked on for it to start making sense. So the data, that is the other part of the computer system that yeah, it's a part of the computer system, and its role is to act as input, what the computer will use to perform a task. Users, you and I, we are considered as part of the computer system. Why? Because we are the ones who specify what we want the computer to do, what we want the computer to do, even the output that the computer will give, we are the ones who are going to use the output. So that's why we are considered as being part of the computer system. We've defined the parts of the computer. The next part that we'll talk about is to look at a key concept that is used in in computers, and that is the input process output concept. Now, in this input process output concept, what we have is we are saying, just from the definition of the computer, you remember we said the computer is an electronic device that accepts input, process the input, generate the output. So this is the concept. Any computer system that you can think of, it uses this concept for it to operate. Now, what do we mean by input? I'll talk about storage later on. Input, we are saying the computer, first of all, has to get input from the users. It's the users who tell the computer what they want to do. Let's say I want to send a message to greet a friend. How are you, John? I am the one who knows the message that I want to send. So I'm going to issue an instruction. If I am using, let's say, for example, yeah, let's say I type the message on a keyboard. How are you? Now, as I type that message and then I press send, okay, the processing now comes in. Some action will be performed on the data. And in this case, it's preparing the data in a form suitable for sending. And when it is prepared, even being sent to the receiver. Now, remember processing, we said performing some action. Now, there are a number of actions that will be done. If I'm sending an SMS, for example, some of the things that will be done regarding the processing will include one, determining whether I have enough airtime for me to send that message. Secondly, determining whether I have specified the receiver's details. And after that, sending to the receiver. Then when the receiver receives, there's also processing, preparing the received data in a way that will be understood or in a way ready for presentation. Now, after the data has been processed, the last part or the next part is to output the data. The next part is to output the data. Okay, so the output, remember we said the users are the ones who are going to use this data. So basically what will happen is the output that is generated has to be given. This output could be in form of some text, sound, image, document, etc. So that's that. Then the last part was the storage. Now storage is one of the processes that are done in computing. When data is worked on, I may want data just to save. Maybe I take a photo and I just want it saved. That is a process. So that's why the process that the computer uses is the input process output concept. So that is the idea. Okay, so I hope that makes sense. I hope that makes sense. So far we have talked about computer generations. We have talked about this input process output concept. We've also talked about parts of the computer system. So that's that. So in the next lecture, we'll start discussing computer hardware, focusing on the different parts of the computer and in which categories they fell. So that is what we're going to discuss in the next video. So I thank you very much for watching this video. I'll see you in the next video.